In this video, we're going to solve quadratic word problems that are written in standard form. So in word problem number 1, it says, a rocket is launched straight into the air from a platform. Its height in meters, x seconds after the launch, is modeled by the following. So here we can see where it says x seconds, we can say that x, or our x-axis, is time in seconds. So that's what this is modeling with x. X represents time. So here, I'm going to draw a little sketch over here so you can kind of see what this represents. And here our x-axis is time, and it starts at x is equal to 0. And what happens here is that our h of x is our height in meters. So here we have our height modeled on the y-axis, and this is going to be in meters. So what happens here is our rocket is launched straight into the air. And as time goes on, that rocket shoots up and it starts going and it's shooting up into the air. But then because of gravity, it eventually reaches a high point and then it starts to fall back down. And the way that projectile motion or motion that goes straight up into the air is modeled is using a quadratic, because it shoots up and it goes up really, really fast at first, and then as it reaches that high point, it stalls. And then as it comes back down, it starts to move faster and faster and faster until it hits the ground. So this rocket model that we have here in this function is modeling x is time, and that's time in seconds, so the seconds that have gone by while that rocket goes into the air, and our y-axis here represents the height. So here in the first problem it asks us, and it says, please find the maximum height of the rocket. And while that might seem like it's a little bit difficult, what we notice here is our maximum height here occurs at this top point. And if you look carefully, this is really a parabola here that would continue on. And this up here is our vertex point. So if we can find our vertex point, we can actually find the maximum height here, because the y-coordinate, remember it's time is x and height is y. If we can find our y-coordinate, our height, we can find what our height is at that vertex point. So to find our maximum height, we need to find our vertex, and to find our vertex, we need to find our axis of symmetry. So we're going to start here by finding our axis of symmetry by using our axis of symmetry equations. Remember, we have x equals negative b divided by 2 times a. So if we use the equation that's provided to us, we have negative 75 divided by 2 times negative 4.688. Which then, if we simplify that a little, we get negative 75 divided by negative 9.376, which, if we divide that out, becomes 7.999, or if we estimate a little, this is about 8 seconds. So what that's telling me is that in this vertex point up here, our vertex point occurs after 8 seconds. So if we can find the height at 8 seconds, we can find the maximum height of this rocket. So another thing to notice here is we've just discovered a pretty key detail. We've discovered that this axis of symmetry occurs at 8 seconds. So we started at 0 seconds, we shot up into the air, and at 8 seconds we reached our highest point. So now what we need to do is we need to utilize our equation here to help us calculate our height at that particular point. So I'm just going to use this equation down here and say negative 4.688 times 8 squared plus 75 times 8. So then from here, this becomes negative 4.688 times 64 plus 75 times 8. So this first part here, this negative 4.688 times 64 becomes negative 300 plus 75 times 8 is 600. So those two added together are 300. So what we find out here is that at 8 seconds, we are at our maximum height of 300 meters. So I ran out of space down here in part A, but our answer here for part A is that our highest point is 300 meters above the ground. Now this last question here in part B says how long is the rocket in the air in total before it hits the ground again? And while this may seem tricky, if you look really carefully here at our parabola, what you'll notice is that this is symmetric. So if it took us 8 seconds to get into the air, it takes us 8 seconds to fall back down to the ground. So we take the 8 plus the 8 seconds to go up plus the 8 seconds to come down. So our rocket was in the air a total of 16 seconds. So here in example 2, it says you are the punter for your football team. You kick the ball and it is modeled by the following equation. X represents the distance the football is kicked away from you in feet, and f of x represents the height of the football in feet. So to give you a feel for what this actually looks like, I'm going to draw a coordinate plane here. And what's really going on is we're kicking that football, and here our football starts. We punt it, it's basically on the ground, and it goes up, 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 up. It reaches a high point up here, and then it comes back down to the ground. So that is a general idea of what's going on here. Here is the distance away from us. So this is how far we kick it away. And here is the height of our football. So what we need to do is we need to find the maximum height of this football, which remember goes along with the vertex up here. This is our distance. I'm going to put distance away. And this is our height. So our x value is our distance away, our y value is our height, and if we can find this vertex point up here, we can actually determine at what distance away and at what height that football reaches its highest point. So in order to start this process for part A, we need to identify our axis of symmetry, which remember is the middle of this graph right here, and it's x is equal to negative b or opposite b, so 5.85 divided by 2 times our a value, which is negative 0.098. So that becomes negative 5.85 divided by negative 0.196. And if I divide those out, I find that the distance away from me from that vertex point is 29.85 feet. So, not the nicest number in the world, but what this number represents is the x-coordinate of our vertex point. That is the distance away from us when the football reaches its highest point. So then this next part says, what is the maximum height of the football? Well, the maximum height of the football is this y-coordinate here. So what we need to do is we need to take our function here, and we need to substitute in 29.85 for our x values. So we have negative 0.098 times 29.85 squared plus 5.85 times 29.85. And then we have to multiply that out in our calculator. Now you can do this step by step using the order of operations, or you can just plug it in as a stream of numbers on your calculator, utilizing parentheses around the number that you substituted, and you'll find that you have a maximum height of about 87.3 feet. So our maximum height is 87.3 feet up in the air. Then part B down here says, how far away from you does the football hit the ground? Remember that our parabolas are symmetric, and because this is based on the x-axis and this is based on the x-axis, what we can actually do is we can take this distance right here, so it was 29.85, and we know that it's the same distance over here, 29.85. So if we take 29.85 plus itself, or just multiplying it by 2, we find that the distance away from us that this football lands is about 59.7 feet away. So when we kick this football, it goes to a maximum height of about 87.3 feet and then lands about 59.7 feet away from us.